Okay, what we're going to look at in this session is Erlang variables, how they're like variables in other languages and how they're different, and also we're going to begin to look at pattern matching in Erlang, and that's related to the way that variables are handled. So, with those two features, we'll be able to define more complicated functions, and we'll begin to start doing some really effective programming in Erlang. Now, what we've seen so far in Erlang is that it works like a calculator. In computation is expression evaluation. We've seen that values come from built-in types, numbers, atoms, lists, tuples and functions. But Erlang also has variables. Now, what I'm going to do in this part of the course is I'm going to show you examples from the shell. And what I suggest you do is that you have a shell running so that you can try out these examples and try out others. And another thing I would say is, one of the nice things about having pre-recorded video is that you can stop it at any time, rewind if you didn't understand something I said, or stop it and try some things out for yourself. So you can have the shell running, see what happens, and you can see that what I'm showing you in my slides happens in the shell. Okay, let's get started. So Erlang has variables. We've seen this already. So we saw the example, an example like this, that you can say a equals 2 plus 3, full stop, in Erlang, and that has the result 5. And then we can use the value of a in setting values of other variables like b. So here we're setting b to be a minus 1, and so b has the value 4. So far, so good. But these are not variables as we know them, Jim. We can set a to be b plus 1. Okay, so we're doing that, and a has become 5. And then we could set a to be b. We get an exception. What's going on there? What we're told is that we're getting no match of the right-hand side value 4. What's happening? Well, let's run through the example again. If a variable doesn't have a value already, if it isn't bound, then equality gives it a value. So saying a equals 2 plus 3 sets the value of a to 5. Saying b equals a minus 1 sets the value of b to 4. But if it is already bound, then equality is a check on its value. It's a match to see, is the thing on the left equal to the thing on the right? So if we say a equals b plus 1, we know that b is 4, so b plus 1 is 5, and that's actually equal to the value that a already has. So that's fine. But if we say a equals b, we get a failure because there's been no match of the right-hand side value. b is 4, and we're trying to match that with the variable a, which is already 5. So these variables are, if you like, single assignment. They are bound once, and once they are bound, they can then be used to match against. We can check whether a new value, something we've evaluated, has the value that that variable already is. So these variables are really not varying. What they are names of values. So we use them to name values. So in this example here, we've named 2 plus 3 to be a, we've named a minus 1 to be b, and then we can use them in defining others. So here we're defining c to be the triple a, and so c is the triple 5, 4, 5. So they're really, variables in Erlang are names, and they're not names that change. So they are, each variable is associated with a fixed value. So they're much more like definitions than they are locations whose value changes in order to make a computation happen. So they are names. Now, we can also use variables as part of patterns. So we can say the pattern curly brackets a comma b, curly brackets equals 2 comma 3. And that binds that pattern to 2 and 3, so it binds each of the components. So B in that gets bound to 3. So we can do complex pattern matching in Erlang by the same process. And once we've got those values, we can use those values in patterns. So here we can say the tuple A, C is matched with 2, 5, and that will result in C getting the value 5, and that's okay because A is already 2. But if we write something like A, D equals 6, 6, we'll have a problem because A is already bound to 2, so that match will fail. But we're able to use bound variables in patterns. You can see in those examples on lines 5 and 6, A was already bound to 2. That was okay in line 5 because C didn't have a value already. So you got bound to 5. In line 6, it was a problem because A was already 2. And incidentally, in line 6, it's not that it partially fails. D doesn't get a value from that at all. So the whole match fails. A remains to be 2. D is not bound. So we can use bound variables in patterns. That's quite different from languages like Haskell, where in a pattern match, the variables are always new, they're never bound. And this is, we will find that it's really helpful to have bound variables in patterns. And Erlang uses those, we can use them in quite a sophisticated way, for example in matching different kinds of messages when we start looking at communication. We can also have repeated variables in patterns, so we can say something like A equals 2, 2, and that results in A having the value 2. But of course if we say B equals 2, 5, we'll again get an error. So in general, when you see an equal sign, it's a pattern match. If the thing on the left is free, it gets the value on the right. If the thing on the left is already bound, it checks to see if it's equal to the value on the right. And if the thing on the left is compound, all the pattern matches it leads to, all the variables it involves have to pattern match successfully, otherwise the whole thing fails. It's like a transaction, if you like. So just to be clear, we can't write loops like the loop up there for summing a collection of numbers. We can't do a similar thing in Erlang. Now, in fact, we'll see we can get that effect without having updatable variables in a different way. When we talk about recursion, we'll see there's something we can do. We'll do that next week. For the moment, just remember that variables, if you like, variables don't vary. Each variable has a fixed value, and that value we can match against, but we can't update. And here's an example just of a transaction in the shell. You can see that you've got that final exception. And just to remind you, we talked about this when we first looked at the shell, we can forget bindings. So you can use f, small f, open brackets a, to forget the binding of a. You can use small f, open bracket, close bracket, to forget all bindings. And that will, but we can only do that in the shell. It's not something we can do inside a function definition. So it's just temporary names in the shell can be rebound, but only explicitly by forgetting their previous value. Now let's have a look at how pattern matching works with functions. Our simplest functions look like those. We've seen that double is times x and 2 and so on. So they're a single clause. But sometimes what we want to do is select different clauses for different cases. So for example, a simple case here is we want to check whether the argument is 0. And you can see what we've done here is we can actually put in a literal pattern, the value 0. We can say is 0 of 0 is true, and is 0 of x is false. And these are matched in sequence. So if it's possible to use the first clause, that is when the argument is 0, we use that. Otherwise, so the second clause is only used when the first clause doesn't hold. And one piece of syntax here, it's the first time we've seen a function with two clauses, and note that what we do is we separate the clauses with semicolons. So the first clause ends with a semicolon, the last clause ends with a full stop. And as I said when I was talking about the previous slide, these clauses are matched sequentially. We use the first one that succeeds. So for 0, the answer is true. For anything else, the first clause fails, we use the second, and that will match because a variable matches with anything. And so for anything else, we get the answer false. Now, let's conclude with an example which we're going to actually follow up in the homework. If we think about Boolean OR, it usually allows both possibilities to be true. But if you go into a restaurant and you're told on the menu you can choose pizza or pasta, you can't usually choose both. Menu OR is exclusive OR. It allows you to have one option or the other, but not both. How can we define an exclusive OR function on Booleans? Well, you can see at the foot of the slide I've put a definition. And this says exclusive OR, if the arguments are true and false, is true. Exclusive OR, if the arguments are false and true, is true. Exclusive OR, in every other case, when the arguments are x and y are variables there, remember, so they match anything, the answer is false. So that would match the case of true and true, and match the case of false and false. So we've got that definition where we use some of the patterns involve variables, some of them involve literals or actual values. Now in the final case, we don't actually use x and y in the definition. So we don't care about their values. So what we do actually is replace them with underscore, because the Erlang compiler, if we use x and y, will warn us that their values are not used. Now that's fine, it's useful to have a warning like that, but if we know that they're not used, why not just put a don't care clause, put a catch-all underscore there. And then you can see that this will, so in the cases that one argument is true, the other is false, we get the answer true, and in every other case we get the answer false. But remember, again, these things are matched sequentially. You can also, we talked about this earlier, you can use pattern matching to check equality. So we could say XOR when the two arguments are the same is false, and otherwise the answer is true. So here we've got a slightly different definition. We're defining a false case first. That's when the arguments are the same, and then the other case, the arguments are different. So we're using the variable x there repeated in order to check that the arguments are the same. So here we're seeing that the patterns we use in function definitions can be literals, they can have wildcards, they can have variables, they can have repeated variables, just as the pattern matching we did earlier on. And so we've seen in this component that we have variables in Erlang that are really names. They are names for the values they get bound to. They are not updatable. We've seen pattern matching in the shell. We've also seen pattern matching in functions. And what we're going to do now is follow this up with a test of what we can do in Erlang with variables and pattern matching, and also a homework exercise to get you to try and define some functions using pattern matching, and in particular to try and see how many different definitions of exclusive OR you can come up with using different kinds of pattern matching. Okay, but that's it for this component about variables and patterns. Thanks.